Alright, so once we have our known quantities and our known values, we want to think of what kind of equations we want to use. And so we want to use this particular kinematic equation here for projectile motion. And we put in what values that we know. And so we find for cosine 45 is 0.7071, or if you know how to do your cosine trigonometry values, you get square root of 2 over 2. So you plug that into your reduced equation. And you want to work through here, plugging in values that you know and reworking the equation to get values that you need until you can solve for t. So you get the equation for t here, and so we can plug that back into our original equation, substitute for t, reduce, and find that v initial equals the square root of d times g. Alright, so we need to save that for a little bit later. Need to move on to the bounce shot. Alright, so first this is broken up into two different pieces. So we have our knowns for the bounce shot here. And so for the first arch we have x1, and we can use our projectile motion again and plug that in like that. And reduce down to this. The same thing for our y values here. Until we reduce and solve for t again, for time 1 for the first arch. And we come down and substitute again, substitute this back in. Alright, and then we reduce the problem and rearrange a little bit and get 2 times velocity initial squared over gravity times cosine theta sine theta. And so we need to use our trigonometric multiplication identities and plug these in here and find that cosine theta times sine theta actually is 1/2 times sine 2 theta. And so we replace that, plug that in there, and reduce and cancel out factors until we get our x1 equation here. Alright, and then we want to move on to the second bounce, which is